we're going to take a look at molecules that are called bicyclic molecules, and specifically one type of bicyclic. And by bicyclic, we just mean that there are two rings within the same structure. The type of bicyclic molecule that we're going to be looking at is one where if you look at one ring, for instance, this one here, and you highlight that one ring, you'll notice that there are atoms connected to one of the carbons. And if you just go from one atom to another, continuous, that it connects back to the ring at a different carbon. These carbons where it connects a second ring, these carbons are called the bridge carbons. And so we're going to be looking at ones where there are two bridge carbons. There are other kinds of rings that would be considered structures with two rings, but this specifically what we're looking at are the ones that have two bridge carbons. So if you look at this, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total carbons, and there are two rings. This one over here, if you look, if you go from one carbon to another, there's one ring, and then connected to this ring is another group, and then it goes back and is connected to another carbon in the ring. And so in this molecule, these are the bridge carbons, and there would be two rings as part of this molecule. This one has 1, 2, 3, 4, 5, 6, 7, 8 carbons present. This is a version of an octane because in the ring system there are 8, and this one would be a version of a decane that is in the bicyclic structure. So we're going to go through how we name these molecules, and it all is based on the bridge carbons. And so you have to locate the bridge carbons, which is here and here. And there are a few things that you do after that. You do what we had just done, which is count the total number of carbons. So starting here, there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 total carbons that are part of the rings. And so this is a version of an octane. Because there are 2 bridge carbons, we call this a bicyclo. So instead of cyclooctane, we call it bicyclo. Then we have to describe how those carbons are positioned. So when you describe them, you start at your bridge and you count how many carbons you have from one bridge to another. So here's one and here's another, but we don't count those. So this is 1 carbon, 2 carbons, 3 carbons, 4 carbons. There are 4 carbons between the 2 bridge carbons. If we look over here to the right, there's 1 carbon, 2 carbon. And then if we look at this connection between the two, there are no carbons between that between this bridge. So there's 4 in one direction, 2 in another direction, and 0 in another. And so this molecule is named bicyclo 4.2.0 octane. These 3 numbers, when you add them together, and then you add 2 to that, you should get this number, because these numbers do not include the bridge numbers. So 4 plus 2 plus 0 is 6, plus the 2 bridge carbons gives us 8, and we said it was an octane. So if we look at another one, if we locate our bridge carbons, which will be here and here, and we count the total numbers of carbons, then we have 1, 2, 3, 4, 5, 6, 7. So again, let's make sure we start here. 1, 2, 3, 4, 5, 6, 7. So that's 7 that are part of the ring. And so this would be a heptane. It is a bicyclo compound because it's got 2 bridge carbons that connect between some kind of bond. And so here's one ring, and here would make a second ring. And so that would be bicyclo. And then we're going to count, and you have to count how many carbons there are between the bridge carbons. So this way there's 1, 2, and this way there's 1, 2, and this way there's 1. And so since there's 2 over here, and 2 over here, and 1 right there, you have to organize those 3 numbers so the largest number comes first. And since they're both 2, then you would just put 2.2, and then the smallest bridge goes last, 1. So to double check, 2 plus 2 plus 1 is 5, plus the 2 bridge carbons makes 7. Now if your bicyclic molecule has something attached, we still have to count the number of carbons based on what is in the ring, not based on something that is not in the ring. So this is a methyl group, and it's not in the ring, it's attached to the ring. So if we look, we can see that there is a carbon here and a carbon here, and there is a carbon that's connected to both of those. So there is the bridgehead carbons. So you have to look carefully because this is trying to show some kind of geometry. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make sure they go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so there are 9 carbons. So this is a version of nonane. And if we look at each of the bridges, then we have 1 on this side, 1, 2, 3 on this side, 1, 2, 3 on this side. And let's see, 3 plus 3 is 6, plus 1 is 7, plus 2, that makes 9. So we're going to put these in order, largest to smallest, so their 3's are the same, so that would be 3.3.1. And then I'm going to put bicyclo in front of that. Now, there's a group, there's a methyl, and just like any other kind of name, if there's a group attached, that goes in front. And so this is methyl bicyclo 3.3.1 nonane. The only other thing we have to do is figure out where is that methyl group. And there are 9 choices. So we have to figure out how to number this. These numbers right here are not how we number the carbon locations. This is just to help us see how big the bridges are. So I'm going to cross these out so we don't accidentally use those. The rule is that you have to number the carbons starting at a bridge. And so one of these 2 carbons has to be carbon number 1. And you have to number them going through the larger of the connection sides. So both of these are 3. So we can go either way with our numbering. And so this could be carbon 1. And if this was carbon 1, then you would number it 2, then 3, then 4, then 5. Then to keep numbering it, you go to the next biggest carbon bridge, and you have to keep going in the same direction. And since I'm numbering it counterclockwise, I have to keep going this way. So this is carbon 6, 7, 8. And the last carbon is always the carbon that's in the smallest bridge. So that'd be carbon 9. If I numbered it the other way, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. Since this group here is closest to this bridge, I'm going to number it because I have a choice. I'm going to number it to give me the smallest number. And so you want the smallest number, but you have to follow the rules, which would be you have to number going through the larger of your connections. And so this is one of the larger connections, and you have to go in one direction once you decide. So carbon 1, carbon 2. So I'm going to put a 2-methyl bicyclo 3.3.1 nonane. So if we look at another one, this is a bicyclo because we have a ring, and if you look, the ring would really be here or here. But you'll notice that you've got 2 carbons that are connected to each other, and they're also connected to something else. And so we end up, this looks like a split. So there is a carbon right there, and it's connected to both of these, and then they're also connected to each other. So that creates a bicyclo compound. So if we count first the total number of carbons, we have 1, 2, 3, 4, 5, 6. So this is a hexane. And we're going to put 3 numbers together, and it's going to be a bicyclo. So starting in our bridge, you have to see how many carbons are on each side. So this is 1, 2, 3. Here's 1. And there's 0 between those 2. Okay, so this is the main portions of the ring. And then we have a double bond right here. And we have a chlorine right here. And so the numbering, it has to go through the section with the 3 carbons first, because you have to go through from a bridge. One of your bridges is going to be carbon 1. And then you have to number it through the larger sections. We have to go through this 3 section first. And then we go to the 1. and then there is no numbering through the 0 because it's 0. So we have to go through this section first, but one of these has to be carbon 1, either this one or this one here. So if I number this carbon 1, this would be carbon 2, this would be carbon 3, 4, 5, and this is carbon 6. If I number it this way, it means that my alkene is between carbons 2 and 3. So this is not, I need to change that. Okay. And so this would be 2-ene. So because I had a double bond, I need to change the ending, and I can insert the location of where that double bond is. So it's after carbon number 2. And then I have a chloro, and it is attached to carbon number 6. So this would be 6-chloro bicyclo 3.1.0 hex 2-ene. If I take a name, so let's do 8 bromo bicyclo octane. Okay, so if that adds together, that would be 6 plus the 2 bridge gives us 8. Okay, so the way that you would draw this is, because it is a bicyclo, you've got 2 bridge carbons. And you would draw 3 carbons between it. So that's not one of them. You don't count that. You would go 1, 2, and there's 3, and then back. So that's 1, 2, 3. And then there are 2 this way. So that would be 1, 2, and then back. And then there's 1 in between. Like that. So bromo is on 8. And so carbon 1 has to be one of these. And the bridge, the smallest bridge, that last carbon, it has to be carbon number 8. And so our bromine is on carbon number 8. So that's how you would go about drawing it. Bridge first, and then draw this many carbons between the bridge, this many the other way, this many the other way. So if that was a 0, you would just connect the bridge carbons without putting a carbon in between it. So practice. If you go back to these 2, copy these 2 down and see if you can give it a name. And I'm going to put a group right here. And let's just put a CH2, CH3. So copy these 2 down and see if you can figure out how many total carbons there are for its main name, and then what the 3 numbers would be that you would put in the brackets, and then with this one what carbon number that group is on.